Okay, class. Today we're going to go through section 3.1 and 3.2. I'm going to combine both of those sections and we're just going to go through the 7 characteristics of analysis. So what we'll do is we'll go over the definitions and the notations for each of those 7. And then I'll show you all how to find those figures and then rounding, which is very important for you all to know. Okay, so we're going to start with the measure of center. There's 4 ways that you can measure the center. So the first one is called the mean. All right, so the mean is another way of writing or finding the average. So how do we find the average? All right, let's go to the definition. We'll go to the book, and the definition of it says that the mean or arithmetic mean of a set of data is the measure of the center found by adding all the data values and then dividing by the total number of data values. So that's what the average is. So in words, you're pretty much adding up all your data and then dividing by the number of numbers that you have, right? So that's in words. In mathematical formula, there is the mean formula for it. So notice you have the symbol right here, right? So that symbol there is the sum. So the top part is the sum. It's that symbol that looks like an E. That's the sum. And then the X means all the data values. So you're taking the sum of all the data values, and then you're going to divide it by N. So that N represents the number of data values. So that's the formula for the mean. So there's 2 notations that we use for the mean. We use the X with a line on top of it that's pronounced X bar. That represents the sample. That's the sample mean. The mu, the Greek letter mu, lowercase Greek letter mu, represents the population mean. So X bar is the sample mean, and the mu represents the mean population. So sample would be if I asked you all, what's your height, right? I just asked you in particular, our class, what your height is. We can take the average. That's a sample. However, if you ask the entire population of San Antonio or Texas or the United States for the mean of their heights, that's a big number. So that would represent the population. So that first one is mean. So you just got to remember, for mean, the mean is 2 symbols. X bar is the sample mean, and mu is the population mean. Finding the average. Okay, number 2 is the median. All right, so median, let's go to our definition of median in the book. A median is the measure of the center that is in the middle, that is the middle value when the original data values are arranged in order from increasing magnitude or decreasing. So that's the definition of median. All right, so symbol wise for median, the notation for it is the X with the little, like a tilde. It's called a tilde, a little squiggly. Normally you see it in Spanish names like Peña, Trevino. You have the little ñ, the little symbol, that's called a tilde. So X tilde would represent the median. Or they sometimes use a capital M or they use the term MED to represent median, but usually you see the X with a tilde on top of it. Now, when you find the median, you got to make sure that you put your data in order from smallest to largest. Then you can figure out what the mean is. Now, it's all dependent upon how many data values that you have. So calculation to find the median, it's dependent again on how many numbers you have. So here's the first scenario. So if the number of data values is odd, then the median is going to be the number located in the exact middle of the sorted data. So if you have an odd amount, it's going to be directly in the middle. So let me give you an example of a problem that asks you to find the median. So let me write down the notation, and then we'll do an example. So let's suppose that I asked students, how many sodas do they consume per week, right? And so here's the list. Number of sodas drank per week. And I put them in order, right? So I have 0, 0, 4, 4, 5, 6, 7, 9. 1, 2, 3, 4, 5, 6, 7, 8. I need one more. And I have another person that has 10. So notice, I'm not drunk, but drank. Right. So notice there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers. So because there are 9 amounts, 9 is odd, I'm going to have a direct middle number. So what you do is you cover up the lowest and the highest, and then you continue doing the same thing. You cover up the next lowest, next highest, next lowest, next highest, next lowest, next highest. Bam, you're stuck in the middle. There it is. There is your median. So that's odd. Right now, if you have an even amount of number, let's say you had 0, 0, 4, 4, 5, 6, 7, and 9, and we left off the 10. Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 numbers. That's an even amount, right? So because you have an even amount, if I do the same procedure, I cover up the highest and the lowest and continue working in, you will see that, let's see, cover up 3, cover up 3. I'm going to have 2 middle numbers, the 4 and the 5. So what you would do is you would calculate, you would have to find the average of 4 and 5. So you would have to add 4 plus 5 and divide by 2. So that would be 9 divided by 2. You end up with 4.5. So 4.5 would represent your median. So again, it depends on the amount of numbers you have. So there's an odd amount, it's directly in the middle. Even, you'll have to take the average of 2 middle numbers. That's your median. Okay. Next one is called the mode. Okay, so the mode, that's the third one, mode. Let's look at the definition of mode. So the definition of mode is the values that occur or occurs with the greatest frequency. So you're looking at the values that are given. You want to choose or select the value or the values that appear more often than the others. Now the notation for mode, this one they usually use a capital M for mode. Kind of like median, but they took that off, and so they use the tilde more often than the mode. So mode they do use the M. So again, that's the mode is the value or values that appear more often than the others. So if there are two sets of numbers that appear more frequent than the rest of them, it's considered bimodal. Any value or values, any values that appear more than others, more than two, it's called multimodal. If you don't have any numbers that repeat, they all appear once, it's considered to be no mode. All right, so let's do an example. So let's say, for example, I have 0, 0, 4, 4, 5, 6, 8. So this one, my mode, would have two of them. Notice that zeros and the fours appear twice each, whereas 5 and 6 appear once. So this would be bimodal. So you would write 0, comma, and 4. That would represent your mode. Another example, suppose that you had 1, 1, 1, 2, 3, 5, 5, 6, right? So which number appears more often than the others? The sets of ones. So your mode would equal to 1. That value appears more often than the others. So what if you had 2, 4, 5, 7, 8, 9? Notice that each of these values appear once. So the mode for this one would be no mode. Because they all appear once. What if we had 2, 2, 3, 3, 5, 5, 7, 7? What would be the mode? Well, because all of them appear twice, there's a four-way tie. There's not one value that appears more often than the others. So your mode would also be no mode because they're all tied up. You don't write 2, 3, 5 because they're tied. They all appear once. So this one would be also no mode. Okay. So we got mode. The next one is called the mid-range. This one does not have a definition. It is simply a formula. So the formula for mid-range is going to be well, let's look at it. You should have it in the book. So let's see. We gotta be consistent. Okay, so there it is. So you have usually they put the formula of the top portion of it in parentheses. So you pretty much on the top, you're gonna get your maximum value, and you're gonna add to it the minimum value, and you're gonna divide the whole thing by 2. So usually we would put parentheses on the top. So parentheses, max plus minimum, close parentheses, and then divide the result by 2. That is your mid-range. Notation, they use a M and a lowercase r. So it looks like Mr. So MR is your notation for mid-range. So here's the formula. I made it nicer. I put parentheses. And then there's your symbol, MR. So if we go back to our data with the sodas, right? And I want to find the mid-range of our soda drinkers, right? Because they are in order already. Here's my max. Here's my minimum. I'm going to add 10 plus the minimum, which is 0, and divide the result by 2. So that gives me 10 over 2, which gives me 5. So 5 would represent my mid-range. Right, so let's summarize. What have we learned? We learned about mean. Mean is the average. Symbol is X bar or the mu, right? That's sample, that's population. We also learned about median. That is the middle value, dependent on how many numbers you have. If you have an odd amount, it's the direct middle. If it's even, you're going to take the average of the two middle numbers. Symbol, X tilde. Mode is the number or numbers that appear more often than the others on the list. Symbol is a capital M. And the fourth one is called the mid-range. And remember that is high plus, put the plus too close, high value plus the low value in parentheses divided by 2. There's your mid-range. And the symbol for that was Mr. Right, M1. All right, so we got, those are the 4 measures of the center. Okay, so now we can go and talk about variation, measures of variation. So this is the part of what we take from section 3.2 is measures of variation. So variation, let's talk about what is variation. So variation measures how the data are spread from each other. Are they close to each other or are they far apart? We want to see if there's any consistency. That's the main issue we want to see, is that consistency. So when you guys see on TV like a drug like Lipitor, and you know, before it goes out to the public, they have to test it, of course, right? So when they describe what the drug does, you know, hey, it relieves cholesterol, but real quick they go through and state the side effects: nosebleeds, death, you know, depression. There has to be some consistency among those side effects. So hopefully those side effects appear in a consistency. If there's 5 of them, then every time they test it on subjects, there's a consistency of all 5s among the side effects, 5 at most or less. So you want that consistency. So that's what variation measures. So if the variation is small or close to 0, that means that the data values are close to each other. If the variation is large, that means that the data values are far away from each other. So I asked you all how much money do you have in your savings account? Well, everyone's savings account is going to be different. I have negatives, but you guys may have money in your savings account, and it just varies. It varies. Some have a lot, some people have a little bit. We all do not have the same amount of money in the savings account. So that's what variations measure. I want to see if there's a consistency among the data. Right. And so that's what variation is measuring. So there are three ways that we can measure variation. So the first one is called the range. Right? So we use a capital R notation to represent range. So I'm going to give you the definition of range. So the definition of range is max minus the minimum. There's no formal definition, so you're simply just doing your subtraction of your maximum value minus the minimum value. Quickest, easiest way to figure out the range. Of course, if you had numbers that had the same number, right, the consistency, let's say for the Lipitor example, right, all the subjects had 5 side effects. They all had 5 side effects. So you had 5, 5, 5, 5. Well, if you had all straight 5s and you take the range, your max would be 5 and your minimum would be 5. So 5 minus 5 gives you 0. So that means there is a perfect consistency among the data. So that's the range. All right. So the next one is a very important one that you guys will see whenever you take chemistry, biology, any of the sciences. And that's a big word that they use a lot, and that is called the standard deviation. Okay, standard deviation. Now, for standard deviation, there's two notations that we use. We use the S. S is the standard deviation found from a sample. So S is sample, and they use for the population data, they use a lowercase sigma. Okay, lowercase sigma is what they use for the population. So there's two notations. We use S for sample, standard deviation. I'm going to have to abbreviate it. And then we use the O, and I'll show you all how I was taught how to remember to distinguish between the O and the S. Okay, so I'm going to show you. This is what I was taught in school. So it may work. You all, we had to memorize all the formulas, but you guys don't. But anyways, if you want to, that's fine. So S, sample, standard deviation, and then the O is population. It's a O with a curl. Looks like a cherry or a blue smoke bomb, right? So there's your symbols. So technically, what you're doing for standard deviation, it's a long formula. If you want to know how to use the long formula, look it up in the book. We don't need to do that. We're going to let Statistics compute it for us. But if you want to do it the long way, you got to read the book, and I'll show you where to find it if you want to do it the long way. But pretty much standard deviation, what it does is it measures the average distance of each value from the mean. That's what the standard deviation is measuring. So every single data value that you have, it measures the distance from the mean from each of those values. And that gives you a value. And again, if that number is close to 0, that means the values are close to each other. Right? If that standard deviation is large, then that means the numbers are spread apart. So that's a very important concept to know in the science field. And for you nursing, doctors, a very important measurement to have and to know when you're doing research. So that's standard deviation. And the third one is called the variance. Okay, so variance pretty much is the standard deviation squared. It's a corny formula, but that's what it is. It's pretty much just the standard deviation squared. Notation, we use s to the second power to represent the sample variance. And we use an O raised to the second power to represent the population variance. And so to summarize the measures of variation, we discussed 3 of them. We had the range. Remember, that was the R. That was high value minus low value. We had the standard deviation. I have to abbreviate it. Standard deviation. We have 2 symbols. We use the S and the O, sample, population. That was the measurement of the average distances among each data value from the mean. That's what the standard deviation was. And we discussed the variance. Variance was the standard deviation squared. So you just pretty much just square, raise it to the second power, raise the standard deviation to the second power, which gives you your variance. So now we covered all 7. So we covered mean, median, mode, mid-range, range, standard deviation, and variance. Right? So now we're going to calculate all those 7. Now, when we use StatDisk or you use Excel, you can use either one. To me, I think StatDisk is pretty much the best choice to choose. Regardless which one you use, you're not going to get the mode correctly from either one of them. Now, in StatDisk, it will not give you the mode. In Excel, it'll give you the mode, but it'll do it correctly if you only have one mode. But if you have multi-mode, it will not work. So, in a nutshell, you will have to do mode on your own. You have to do it by hand manually. Everything else, it'll compute the other 7. All right, so let's see, how do we find all those 7 things on StatDisk? Okay, so let's go to our StatDisk, and let's see if we can show you how to do one. All right, so I'm gonna load up the data, and I'm gonna load up we'll do body data. No, we'll do foot and height. Yeah, so here's my data, foot and height. And I want to find all those 7 parts for the foot length. Now, the thing is, you're going to have to do some rounding. So I have to show you all the rules for rounding. So remember, we do not do significant figures in this course. We pretty much just do regular rounding. So the rounding rules, and I can show you in the book, this is how the rounding rules go. So it works the same for mean, median mode, mid-range, range, standard deviation, variance, same thing. So here are the rounding rules. It says the rounding rules for measure the center and measure variance. You need to carry 1 more decimal place than is present in the original data set. That's the rule. Okay, now let's talk about that. Okay, so because you're gonna probably get confused about the rounding rules. All right, so here's how it works. So I'm gonna have a little chart to explain to you how the rounding procedures work. So you're gonna have to look at the data first. So you're going to observe how all data are given. Very important. You got to look at all the data. How are they all given originally? All right. So if the given data are given in whole values, they're all whole numbers. Okay. The rule says that you have to go 1 place further back. So that means when you find the 7 characteristics, you're going to round to the tenths. That's how it works. Whole numbers, you got to round to the tenths. If your numbers are all given in tenths, then you're going to round all 7 to the hundredths. All right, so this is one decimal place behind. 1 decimal place behind. This one's 2 decimal places behind. Right? If you're given in hundreds, then you're going to round to the 10,000. Sorry, you're going to round to the thousands. Thousands. They get excited. Thousands. Right, that's 3. And so forth. It's always it's always 1 furthermore. That's pretty much. And you can keep going. You can keep going. It's always one further back. That's how the rounding rules work. Whatever's given, you need to make sure that you have 1 more decimal place further back than how these are given. So it's always 1 place further back. That's how the rounding rules work. Okay. Now let's do an example. So you can see how those rounding procedures work. All right, so let's go back to our data for our stat disk. And we're going to do the foot lengths. So I went to data sets, I did a 6th edition, and I picked foot and height and then uploaded. Well, changed it. Oh, what? All right, let me see. What did I do? All right, let me clear it. Okay, we load it up again. Data set, 6th edition, foot and height. All right, now let's find all 7 parts to the foot lengths column. Okay, so notice on your foot lengths, notice that all of the numbers from the first to the 40th value, they are all given in tenths. There's one place behind the decimal, so that's a tenth spot. So when I do so all of them have tenths, right? So when I go and do my rounding, when I find all 7 pieces, I need to make sure that they're in tenths. I need to make sure that all my answers end up being in the hundreds. I need 2 spaces behind, 2 decimal values behind the decimal on all of my answers because they're in tenths. I gotta go hundreds. All right, so here's what you do. So because we have our data in StatDisk already, I don't have to put them in order, unless if you want to, we could. I can show you how to do that. If you want to put foot lengths in order, all you have to do is hit Data Tools. You want to hit Data Sort, and I want to sort one column. I want to sort the foot length, and I want to sort it from A to Z. That's from smallest to largest. And I hit Sort. Boom, they have been sorted. All the numbers are from smallest to largest. Why did I do that for? Well, that's probably going to help me find the mode, the number that appears more often than the others. All right, so now that I have them in order, I want to go ahead and find all 7 pieces. So you're going to click on this Data Tools here, and I'm going to click on Explore Data. I'm going to select foot lengths, and I hit Evaluate. And presto, there is all of the items that I have except for mode. That gives me what I need. All right, so let's jot it down. So we are finding for the foot lengths, we need to find the mean, median, mode, mid-range, range, standard deviation, variance. Right, and you can see that it gave us everything except for mode. Yes, and you're gonna ask me, sir, can we use this on the exams? Yes, you can. Yes, you can. All right, so let's see. All right, so for my mean, I need to make sure. Remember, my original data had a tenths value behind the decimal, which means I have to round all my numbers and have 2 digits behind the decimal. So here's my mean. So my mean is 25.68. My median is 25.50. I want to make sure that that digit has 2 decimal places behind the decimal. So that would be 25.50. 50. We'll come back and do the mode in a minute. My mid-range is 25.55. My range would be, it's my range, 7.30. 7.30 is my range. My standard deviation is going to be 1.98. That 6 is going to carry over to the 7, so that's going to give me 1.98. And my variance is going to equal to 3.91. The 8 is going to change that 0 to a 1. 3.91. And now I have to go back and look at my original data to find my mode. So I gotta find the value that appears more often than the others. I think it's going to be 23.8. Let's see. 1, 2, 3, 4. 23.8 appears 4 times. 1, 2, 3. Yep. It looks like the winner is 23.8. 23.8 appears 4 times. That's the most. Right. So notice that my data are given in tenths. My answers have to have 1 decimal place more. Which means they have to have 2 values. Right? So there they are. They all have 2 values behind the decimal. Now, you're going to ask me, well, sir, there's a 0. Do I have to put a 0? Yeah, go ahead and put a 0 just to be consistent. I want all the numbers to be consistent. So all of them should have 2 decimal places behind. So again, you had tenths as your original data. I want hundredths. Okay. Now, if you all have trouble rounding, okay, I can show you how Excel can help you round. Okay. Now, what we can do is I can do my analysis again, explore data, what lengths. I can copy it. Well, maybe not copy the whole thing. I just want the mean. I just want this part copied. I'm going to copy it. And I'm going to open up Excel. Let's see if it opens up. And I can show you that it can oh, Excel. Okay, hold on. Shared with you. So what I did was I pasted the data, the results on an Excel spreadsheet. And I want to, how do I do this? I'm gonna take, I just want the number. Okay, so what I'm gonna do is I'm gonna remove the value, cut, and put it in column B. Median, I'm gonna cut. I have to break it off into 2 parts because it's giving me 1 column. So I'm gonna just, I don't need RPM, I don't need that one, delete. Variance, yeah, variance. Put that piece. Segregation, definitely. I don't even need that value. I need that. And I have the range. So, okay, so there we go. I'll make it prettier. I'll put them in. There we go. All right. So let me show you a little trick. So all I did was I pasted the analysis from StatDisk into Excel. I had to go on each cell and split the mean and the number and make 2 separate columns. Right. So, and you're having trouble with rounding, right? So look at column B. I'm gonna highlight. I'm gonna click, hold, and drag. And if you go to on your home tab, if you move over to where it says general, there's a little general tab right there. Underneath it on the bottom right, there's 2 buttons. You have 1 arrow with 0 and 0.00, and you get another one facing right, an arrow, blue arrow, decrease decimal. This is going to help you round. So because I want numbers, all my answers, the 7 characters, to be rounded to the 2 decimal places behind the decimal, right? I can always adjust it. So I can use the left one to make more values, or I can cut it off. I only wanted 2 decimal places behind the decimal, and bam, it did it for you. So you can tell Excel how you want to format all your answers, and it'll do the rounding for you. Ain't that cool? Yeah, cool. So you have to make sure that you understand the rounding rules. Okay, so let's do another one. So let's go back to our stat disk. And let's go back and let's do one where I have more digits behind the decimal. So I'm going to go to data sets and I'm going to pick on 6th edition. I'm going to pick tornadoes. Where's the tornadoes? There's the tornadoes. And I want to find all 7 things, all 7 characteristics of analysis. I want to find everything: mean, median, mode, mid-range, range, standard deviation, variance. And I want to do the lengths of the tornadoes. How long were those tornadoes? Now, notice how the data are given. I have 2 decimal places behind the decimal. That's 2. So that's all of these numbers are in hundreds. Right? So let's go back to our rounding rules. Since my values are in hundreds, where do I round it off? Okay. They're all in hundreds. So let's go back and look at my notes. Because all my numbers are in hundreds, all my answers, all 7 items have to have 3 values behind the decimal. They have to be in thousands. I have to have 3 now because there's 2 answers should have 3. It's always one place for the back. All right, so let's go back and have Excel or have StatDisk do my analysis for me. So I want to put these in order. The data tools, I'm going to sort the data. I'm going to choose one column. I'm going to do lengths, and I'm going to put them in order from smallest to largest. Boom, there you go. So I put everything in order by length. Okay. Now I want to calculate the mean and all that stuff, right? All 7 things. So I'm going to hit data tools again, and I'm going to click on explore data. I'm going to select lengths, and I hit evaluate. Right? And there is my analysis on the left. So I want to do for the tornadoes. I want to find the mean, median, mode, mid-range, range, standard deviation, variance. And I got to make sure that there are 3 values after the decimal. Got to be 3. All right, so how should I do it? Should I? Yeah, that's a good idea. Let's do Excel. So I'm gonna copy my mean up to range. I'm gonna paste it. I'm gonna copy it. I'm gonna paste it on my Word document, on my Excel document, not Word. My Excel document. All right, I'm gonna paste it. Share my screen. All right, and I gotta adjust it. So I need to cut. It's a pain in the butt to do it, but hey, it's gonna give us the answers. Change, cut. I'm cutting and pasting. That one. I don't need this one. Cut, 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 paste, cut, paste. Ah, no, bunch of yeah. Okay. All right. Now I should put another. I should insert mode on there. All right, here we go. So I need to make sure that all my numbers have 3 decimal values after the decimal. So I'm gonna left click, hold and drag, and I'm gonna use this feature underneath the general, and I'm going to cut it so that I have 3. And there are my answers. So I need to go back and go look at my data to see what my mode was. I don't remember what my mode was. Let's go back to my data. Original data. Mode. All right, so my mode is, I see 2.06s, 2.0. Ooh, it looks like 0.10. I'm gonna say 0.10. Oh, 0.20. Ooh, whoa. This is gonna be tough. Wow. Okay, so let's download the data in Excel. That's a tough one. Okay. This is gonna be tough. All right, so let me delete these. I only want the links. Okay, go on. I only want the links. So let me get rid of these. I don't need these columns. Paste. Oh, I want to delete them. Delete. I don't need the width either. Delete. All right, let's see. All right. Let's see, how many 0.10s do I have? All right, so I'm gonna do my little trick that we did before. I'm gonna let Excel count for me. I'll let Excel count for me. So let's see, how many 0.10s do I have? Okay, so I'm gonna left click, hold, and drag. Okay. It says here in the very bottom, there's 128. All right, 128. Okay. All right, let's see. Let's count how many 0.20s do I have? 0.20s. This one says 45. 45. 45.2. Oh, I got another one. 0.30. Drag. 30. That one has 30. 30 of them. 30.30s. Let me see. I think the 0.50s repeat often. All right, let's see. Click hold. 50. Oops. Nope, there are 40 of them. 40.5s. 40.5s. Oh, a lot of 1.0. Let's see. Left click hold. Let's see how many ones do I have. Oops. There are 43 of them. So far, it looks like 0.10. Twos, a lot of twos. All right, let's see the twos. Left click hold. Twos. Gone too far. going to cut it. There's 31. I I cut it too much. I cut it too short. Is it? Try again. 0.2, 0.2. Yeah, there's 31 of them. 31 of them. And there's 400 data. Okay. Well, it looks like 43, 40, 30, 45. Yep, I think the 0.10 is your answer. So 0.10. So I can find the data. Where's the there it is. 0.100. So there's your mode. So all of them have 3 digits because all of those 7 characteristics have 3 digits because the original data had 2. So answer should have 1. All right, and that's the rounding rules for our course. There'll be other rounding rules later on, and we'll talk about it later as we go along. But this is how it works for sets.